What's up guys, how's it going? So today we're going to solve the reverse linked list problem. I'm going to assume that you know about linked list before you solve this problem. So this is a pretty famous problem. You are given a head of a single linked list and you have to reversing the linked list, and then you have to return the head of it, the head of the reverse linked list. So what does reversing a linked list actually means? So in linked list, the nodes are pointing to its next node like you can see on this list. But when you reverse it, the pointers will change. So here the node 1 is pointing to node 2, but in a reversed order, node 2 will point to node 1, node 3 will point to node 2, node 4 will point to node 3, and node 5 will point to node 4. So let's see how we can solve this problem. So first, let's just ignore this part of this linked list. So how can we solve this linked list where we have only two nodes? Well, we just have to reverse the order. So node 2 will point to node 1, and node 1, since it doesn't have any previous node, it will point to null. So this simple linked list is now reversed. Now let's just think of these two as our linked list. So 2 was pointing to 3. So what will happen is, so node 3.next will now point to 2, and node 2 was already pointing to node 1. So this part of the linked list is actually solved. So we just need to do this operation on every single pair of the linked list until we hit the end. We can do this recursively, or you can just simply use a while loop. So let's understand the algorithm a bit more. So we will have our previous node and we will have our next node. I will explain the temporary node in a moment. So our previous node initially would be 1 because there isn't any node before that. And our next node will be 2 because previous node.next is 2. So this will be our initial values, and we will start looping over from the second node, not the first node, because the node 1 will actually point to null and we don't need to do that inside the loop. So we'll start from node 2, and we can also put the first node in the newly linked list. We can start looping over from the second element. So on each iteration, the next node should point to the previous node. So node 2 will now point to node 1. But if we do that, we will lose the link of this node 3. We don't want that. So before we point the next node to the previous node, we will store the next node to a temporary variable. So I can put 3 here as a temporary node, and now we can link 2 with node 1. And now we need to reassign the variables. And since we already visited node 2, our previous node will be now node 2, and our next node will be our temporary node, which is 3. And we'll keep doing the iteration until the next node is null. So on the next loop, node 3 should point to node 2, which is our previous node, but we will store the node 4 as our temporary node first, and then we can put the next node 3 here, and our previous node now will be 3, and the next node will be 4. On the next iteration, 4 should now point to 3, and we need to store the next node to a temporary node, which is null. So now our next node can point to the previous node, and the previous node this time again will be 4, and the next node will be null. And since the next node is null, we don't have any other node to visit. So we have successfully reversed our linked list, and finally we can just return our previous node variable, which should point to our new head node. Now the time complexity of this algorithm is O of n because we have to loop over every single node, and the space complexity is constant because we are not creating any extra data structure. So it's a pretty simple problem. Let's code it up. So first we can check if the head node is null or not, or the head node's next node is a null or not. If any of them is null, we can just return the head variable. And now we can create those variables that I have talked about, which is first the previous node, which should be our head node, and our next node, head.next, and our previous node should point to null. So previous node node.next should be null. Now we can start looping. So if next node is a truthy value, it's not null, then we can create a temporary variable to store the next node's next node. So const temp will be next node dot next, and the next node should point to the previous node. So next node dot next should point to previous node. And now we need to reassign those variables. So previous node will be next node, and the next node should be the previous node. Sorry, not previous node, it should be the temporary node. And after we have looped over the entire linked list, we can just return the previous node. So let's run the code. It should work. Okay, it has accepted the solution. Now we can also submit it. Okay, so it has passed all the test cases. So that's it for this video. If the video has been helpful for you, don't forget to like, share, and subscribe to my channel. You can also check the blog for reference. You can also check my full stack web development channel, Cules Coding. The link will be also on the description. So have a nice day, and I'll see you in the next video. Goodbye.